Welcome to the Network Plus Prepcast, your dedicated audio companion for mastering every objective on the CompTIA Network Plus certification exam. This series is produced by baremetalcyber.com. In episode 132, we explore 3 critical techniques used to increase network efficiency, reliability, and fault tolerance. These traffic distribution methods are commonly deployed in enterprise environments, especially in systems that demand high availability and continuous access to applications or data. Whether you're managing a cluster of web servers, a storage network, or a virtualized host, knowing how to distribute network traffic can make the difference between performance stability and service disruption. For Network Plus candidates, these concepts are often tested in scenarios involving fault tolerance and link optimization. This episode covers the purpose and implementation of load balancing, multipathing, and NIC teaming, 3 separate but related technologies that all aim to improve uptime and performance. Load balancing helps distribute requests evenly. Multipathing ensures storage traffic has alternative routes. NIC teaming aggregates interfaces for higher throughput and failover. Together, these techniques support redundancy, reduce single points of failure, and help networks scale efficiently. On the exam, expect questions on their configuration, use cases, and differences. Load balancing is a method used to distribute traffic evenly across multiple resources to ensure no single resource is overwhelmed. This can apply to web servers, application servers, or network links. By spreading out requests or connections, load balancing improves responsiveness, prevents bottlenecks, and increases the availability of services. It's particularly common in environments where a high volume of users or devices is accessing the same service. On the exam, you may be asked to recognize load balancing in network or service design questions. A load balancer is the device or software tool responsible for managing and distributing incoming traffic. It acts as the front-facing system that receives user requests and forwards them to one of several back-end resources. It also monitors the health of those resources, ensuring that traffic isn't sent to servers that are offline or performing poorly. Load balancers can apply distribution rules based on various criteria to optimize traffic flow. On the exam, expect to identify how load balancers work and what role they serve in system architecture. There are multiple methods that load balancers use to decide where to send traffic. Round-robin distributes requests in sequence to each resource, cycling through them evenly. Least connections chooses the resource with the fewest active sessions. Application-aware routing makes decisions based on request types, user sessions, or Layer 7 data. These methods are chosen based on the needs of the system and the behavior of the traffic. For the exam, you should be able to match load balancing methods with appropriate use cases. Multipathing refers to the use of multiple physical or logical network paths to connect a source to a destination. It is most commonly used in storage networking, where servers connect to storage arrays over more than one path. These paths can carry traffic simultaneously or serve as backups in case one path fails. Multipathing helps ensure continuous access to storage, which is critical for databases, virtual machines, and file servers. On the exam, you may be asked about multipathing in relation to redundancy and storage network design. In storage area networks, or SANs, multipathing plays a vital role. It allows I/O traffic to be distributed across multiple paths from a server to its storage device. Not only does this balance load across links, but it also ensures that if one path becomes unavailable, the traffic reroutes through a remaining path. Many storage drivers and operating systems support multipathing natively, making it a default configuration in enterprise setups. The exam may include scenarios involving SAN connectivity, where multipathing ensures data access. It's important to understand the distinction between link aggregation and multipathing. Link aggregation, also called port channeling, combines 2 or more interfaces into a single logical interface. This increases available bandwidth and supports failover, but requires the links to be treated as one connection. Multipathing, by contrast, keeps the paths separate and uses software logic to manage traffic distribution and failover. Both approaches improve performance and redundancy, but they are used in different contexts. On the exam, you'll need to compare these technologies and apply them to the correct scenario. Network interface card teaming, or NIC teaming, involves combining two or more physical network interfaces on a server or device into one logical interface. The goal is to increase bandwidth, support failover, and provide more reliable connectivity. If one NIC fails, traffic continues over the remaining interfaces without service interruption. This setup is common in servers, firewalls, and hypervisors that require uninterrupted access. On the exam, expect questions that describe NIC teaming as a way to avoid single points of failure. NIC teaming can operate in different modes. Active standby mode designates one interface as primary, while the others serve as backups that activate only upon failure. Load-balanced mode distributes traffic across all available interfaces simultaneously. Some teaming modes require support from the switch, such as LACP or Link Aggregation Control Protocol, while others work independently. Selecting the correct mode depends on hardware support and network goals. On the exam, you may be asked to recognize teaming modes or identify which ones require switch configuration. Configuring any of these technologies requires attention to technical details. Interfaces should be matched in speed and duplex to prevent mismatch errors. NICs in a team must belong to the same VLAN or subnet to ensure consistent traffic flow. Configuration may involve switch-level support, device drivers, or operating system settings. Testing configurations in a lab environment before deployment helps prevent service interruptions. The exam may present configuration scenarios where link issues are caused by mismatched parameters or improper teaming. For more cyber content and books, please check out cyberauthor.me. Also, there are other podcasts on cybersecurity and more at baremetalcyber.com. The performance benefits of load balancing, multipathing, and NIC teaming are significant in high-demand environments. These technologies help reduce network congestion by spreading traffic across multiple links or endpoints. They increase aggregate bandwidth, allowing more data to be transferred simultaneously without overwhelming individual resources. By using all available paths or interfaces efficiently, organizations can improve response times and ensure consistent user experiences. On the Network Plus exam, expect to recognize how these technologies contribute to performance optimization and why they're used in enterprise designs. Beyond performance, redundancy and fault tolerance are core advantages of these traffic distribution techniques. If a single link, NIC, or switch fails, properly configured systems can automatically reroute traffic through alternate paths. This means users don't experience downtime, and services continue uninterrupted. Redundancy is especially critical in data centers and cloud environments, where even brief outages can have significant consequences. On the exam, you'll be asked how failover works and which technologies prevent outages by maintaining active alternate paths. Virtualized environments rely heavily on these techniques. Virtual machines and hypervisors must maintain constant access to networks and storage, and any loss of connectivity can cause application failures. By connecting hypervisors to multiple network or storage interfaces using teaming or multipathing, administrators can protect against single points of failure. Integration with virtual switches, also called vSwitches, allows traffic from multiple VMS to benefit from load balancing and failover. The exam may include virtualization scenarios where these technologies are part of the correct, high-availability design. Monitoring the effectiveness of load balancing involves tracking traffic distribution and endpoint health. Dashboards on load balancers and network management systems display real-time throughput, session counts, and status indicators. These tools help ensure that no single node or path is overused while others sit idle. Monitoring can also reveal misconfigurations, such as when one server is receiving all traffic due to incorrect policy settings. On the exam, you may be asked to identify how administrators verify that load balancing is functioning as intended. When problems arise, troubleshooting link or path issues requires a detailed inspection of interface status, port activity, and configuration settings. Technicians should check for mismatched speeds, incorrect VLAN assignments, or failed interfaces. Failover testing, intentionally disabling one path, can confirm that redundancy mechanisms trigger correctly. Reviewing logs and counters helps identify whether traffic is flowing evenly or if one path is failing silently. Expect exam questions that present symptoms of link imbalance or failover failure and ask you to identify the misconfiguration. Compatibility with network infrastructure is critical when implementing these technologies. Some switch models require specific features like LACP support for NIC teaming or port channel configurations for aggregation. Firmware versions must be compatible across devices to ensure consistent behavior. It's best practice to test any changes in a lab or staging environment before deployment to production. On the exam, be ready to answer how infrastructure compatibility affects the success of teaming or load balancing implementations. The Network Plus exam includes terminology and use case questions on these topics. You'll need to identify when to use NIC teaming versus multipathing, how load balancing distributes traffic, and what conditions cause failover to occur. Matching technologies to appropriate environments, such as using multipathing in storage networks and load balancing in web applications, is key to answering questions correctly. These scenarios often test both conceptual understanding and configuration awareness. In summary, traffic distribution techniques like load balancing, multipathing, and NIC teaming enhance network resilience and efficiency. They enable continuous service, optimize bandwidth, and eliminate single points of failure. These tools are fundamental to designing networks that scale and adapt under pressure. Whether protecting a virtualized environment or a customer-facing application, these methods ensure service continuity and performance. On the exam, you'll need to connect each technique to its purpose, method of configuration, and operational benefit. To conclude episode 132, remember that uptime and performance depend on how traffic is routed, balanced, and protected. Load balancing spreads the workload. Multipathing creates multiple storage or network routes. NIC teaming ensures that even if one interface fails, the others keep traffic flowing. These solutions form the backbone of high-availability networking. Mastering them will help you pass the exam and build infrastructure that stays strong under load. Thank you for listening to this episode of the Network Plus Prepcast, your trusted audio guide to the CompTIA Network Plus certification. This episode was produced by baremetalcyber.com. For more cybersecurity podcasts, books, and resources, visit baremetalcyber.com. Thanks for joining us for this episode of the Bare Metal Cyber Security Plus podcast. For more episodes, tools, and study support, visit us at baremetalcyber.com. And before you take the test, make sure to check out the practice questions in the book Achieve CompTIA Security Plus SY0-701 Exam Success by Dr. Jason Edwards. They cover every domain and are a powerful way to lock in your knowledge.